Hello, this is the Chapter 9 presentation on air masses and fronts. And what I will be doing here is walking you through the very first chapter on the severe weather unit. And we are going to discuss kind of the key makers of how kind of severe weather systems, and in particular weather in the mid-latitudes where we live, effectively are caused as winds move air from different parts of the world to interact with one another. It creates almost like a military-like battle zone, and that'll be the theme here of discussing what are all the kind of building blocks that go into building precipitation events and severe weather, and the key actors in this story are air masses and fronts. Air masses are absolutely one of the backbones of the unit, and they're sort of a way of looking at air coming from different parts of the world that bring different characters of temperature and humidity. And the boundaries that separate air masses are like the boundaries of states, like Indiana and Illinois are separated by a boundary. The boundary between air masses are called fronts, and these are where air masses kind of collide together. And we're going to discuss the interrelationship between air masses and fronts throughout this whole chapter. And without connecting the two, you really won't understand probably what causes and drives weather, in particular in the Midwest of the United States. So hopefully I'll be able to give you some examples. And there are a couple of maps that are missing that I really wish were included, that I'm going to include in this lecture, that hopefully kind of explain a little bit more about them. But the key thing here to understand is, as we get set, is in some parts of the world, like where we live, air that comes into our area is regularly changing direction and coming from different parts of the world. Sometimes it comes off of an ocean, sometimes it comes off of a landmass, sometimes it comes out of the north, and sometimes it comes out of the south or west. And as wind directions shift, they come from different source regions. And source regions are areas of the world where air masses acquire their humidity and temperature characteristics. And this tells you what air masses bring to the table in terms of understanding weather. When you regularly live in Illinois, you'll notice one day could be very warm and humid in April, and then a day later it can drop 30 to 40 degrees and be very cold and dry, or wet for that matter. And the reason why is that the air is coming from a different area of the earth, and depending upon whether air comes from Canada or off the Gulf of Mexico, you're going to have very different conditions. But it's the combination of putting the moisture characteristics together with the temperature characteristics, which allows us to put the two words together. Maritime and continental define the moisture level. Maritime air masses come off of oceans. Continental air masses come off of land masses. Maritime air masses are humid. Continental air masses are dry. Temperature air is defined by which direction the air comes from. If it comes out of the south from the equator, we call it a tropical air mass. If it comes from out of the north, like out of Canada and Illinois, we would call it polar. And if it comes from much further north, clear down near the North Pole, we would call it an Arctic air masses. So when you put the moisture characteristic together with the temperature characteristic, we can kind of get an idea by wind directions. What is the wind bringing us? Is it bringing us humid air that is warm, or is it bringing us air maybe from the north that is dry and cold? These criteria will be the key to understanding how weather is going to shift on the day-to-day basis. Now, the fascinating thing we will discuss with fronts is what happens when air masses of different characteristics meet one another. And that's where we come up with the analogy of predicting weather as like a war, because we will see air masses are like people with personalities, and they often don't get along, and when they do come up against one another, they're like two opposing armies colliding on a battlefield, kind of vying for, contesting for space and territory, pushing up against one another. So The thing that your book does a good job of is it does a very good job of laying out the names of the air masses and where they're from and what are the characteristics of their air masses. It's almost like looking, and as you can see, the humidity is always identified first by either being continental or maritime, and the temperature profile is identified second. So a CA air mass is a continental Arctic air mass, and you could then see where do those air masses come from and what are the properties of the air mass in terms of how does it affect or change weather. What I don't like about the book is they don't show you where these air masses are in relation to one another in terms of where they come from on a map. And I think it means so much more. And I'm going to bounce off of here real quick, and I'm going to go to another slide here for you. And I have one here that I think even does a better job. And on this slide here, we could see all the air masses you just saw on the table, but you really then begin to see the dynamics of the air masses of where they come from. So you got your continental polar air masses, which is your classic Canadian air masses, and how they come from the middle of Canada. And we would expect coming from the middle of a landmass, these CP air masses would be very cold or cooler, and they would be dry because they're coming from the middle of a continent where humidity levels are much lower. So CP brings in cold, dry air. Then we see the sort of the opposite air mass coming off the Gulf of Mexico here. This would be a warm tropical air mass. It would be very humid because it's coming off the Gulf of Mexico, which is very warm and evaporating, and it's coming out of the south. Continental tropical air masses are more of your desert air masses that produce the southwest desert of the United States, and it's very hot, dry air coming from northern Mexico and southern Arizona and southern Nevada, southern Texas. And then you could see what's fascinating is you could see how these air masses kind of all collide over the middle of the United States, and the boundary between these two air masses is often the jet stream. It's a wind that moves west to east, and it's the boundary of the jet stream that separates the polar and tropical air masses that often determines where storms and severe weather and fronts will be occurring that we'll discuss in the next section or video 2 for air masses. So what I wanted you to see is the fascinating position of Illinois and looking at the Midwest, and in particular looking at Tornado Alley, which we will discuss in later chapters, how Tornado Alley and where we will see some of the most severe and dangerous weather in the world kind of erupts on the boundary, kind of where continental polar air masses and tropical air masses coming from the south often collide and meet and are separated by the polar jet stream moving over the United States. Very interesting from an Illinois position. I would ask you if the jet stream was moving way to the north on a given day, maybe up towards Canada, that would then pull up the tropical air masses, and that would obviously produce unusually warm, humid conditions. Say in the month of April, if we had the jet stream way up here, we would actually see maybe the temperatures in Illinois would be feeling more like you would see down in Texas or Louisiana, and we would have very hot, humid days maybe in the 80s and with high humidity. Well, then in turn, what would happen if the jet stream in April moved way down to the south? Well, on those days, we would be bringing in cold Canadian dry air, and it would feel more like winter again, and we would drop maybe down in the 40s or 50s. And it would feel more like maybe February or March again. So depending upon where the jet stream is, often these air masses on a day-to-day basis are moving, and they're regularly pushing into one another, driving each other out of their way. And that's what will lead us to the second video that we will talk about, which is back on fronts and what kind of weather occurs when one air mass invades another air mass's territory, and what kind of weather do we see associated when we see these air masses invading each other's source regions, and how does it affect the people and the pathway of those moving air masses.